Now in section 1.4, this is on special types of linear equations. The first type is the conditional equation. This is actually the type we worked on in the last section. So conditional equations are equations that are sometimes true and sometimes false, depending on which values are substituted for the variable. A conditional linear equation has one solution. So in any question that we might have solved in the last section where we got an answer like x equals 2 or x equals negative 3/5, whatever the x value happened to be, there was one answer for x, and so that was a conditional equation. So this is the usual case. Where you say something like x equals 2. Now, an equation that does not have any solutions is called inconsistent. And so the answer to an inconsistent equation is going to be no solution. And that's what we'll actually need to write as the answer. So if it's going to be an inconsistent equation, it has no solution. And the last type is the type that is true for all possible values of the variable. That's called an identity. So an identity equation it's true for all possible numbers, so it has all real numbers as solutions. Okay, so the actual answer we're going to give for this kind of problem is going to be all real numbers. All right, so we're going to solve 3 different equations on this page. Likely that one of them is going to be conditional, one is going to be inconsistent, and one's going to be identity. We'll see if that turns out to be the case. All right, so part A. I want to solve this equation. So the first thing I want to do is simplify each side. I got my 3x here minus my 7x. That's going to be negative 4x plus 2 equals, and on the other side, we've got a pair of x terms right there. So 5x minus 9x is negative 4x plus 8. Now we're ready to move one of the variables to the other side. I have negative 4x here, so let's add that to the other side, add 4x to both sides. Okay. This time, the negative 4x and the 4x eliminate, they add to 0. So I just have 2 as the only piece left, equals negative 4x plus 4x adds to 0x. I don't have any x left, so I just have the 8 left. Now in this statement, 2 equals 8, this is false. And so that's going to be a key factor for the inconsistent case. These are false. Make that note up ahead. Those are false. You did not get something where you got x equals, and you did not get a true statement. That means there's going to be no solution to these. So I have to write that. So the answer is that there is no solution. Now, I was also told, besides just solve, I did the first part here, solve. I'm solving it, the answer is no solution, but I'm also asked to state what type this was, whether it's conditional, inconsistent, or an identity. So it's no solution because its type must be inconsistent. I can't really tell what type it is until after I've solved it. This is just the type. And the actual answer is no solution. All right. Looking at part B, we're going to solve this one. We're going to use the distributive property first. So we have our 4 times 2 is 8x. Then our 4 times negative 3 is negative 12. Equals our 5 minus x. I like to get my variables on the same side first, moving the smaller one, this x over here. So it's negative, so I'm going to add x to both sides. So that gives us 8x plus 1x is 9x minus 12 equals 5, and then the x is eliminated over there, they add to 0x. And then I can continue solving this one by moving the number to the other side. It's negative 12, so we'll add positive 12. We're working away from the x there. So this gives us 9x equals 17. And to solve for x, I can divide both sides by 9, trying to isolate it. So I have x equals 17 ninths. It's not a very pretty number, but that is the number. So I have one solution right here of x equals 17 ninths. It doesn't reduce, that's the answer. If I get a single answer, then I have one solution. So that means that my equation here was conditional. So the type for this one is going to be conditional. Now, just like when we were solving these in section 1-3, we don't always write conditional next to something when we solve it. I don't always write inconsistent next to it when I solve it. I'm just identifying the types right now. The real answer to the equation would be no solution in the first one and x equals 17 ninths in the second one. Let's look at the third. Okay, I need to start here with distributing as well. So we have 2 times x is 2x, and then minus 2 times 5 is 10, minus x equals x minus 10. I have like terms on the left, 2x minus x. I don't do opposites unless I'm going to the other side with it, so I just add up the two like terms. 2 minus 1 is 1, so I have x minus 10 equals x minus 10. When I try to get my variables on the same side, I'm going to subtract this x from both sides. Subtracting the x gives me no x, so I'm left with just negative 10 equals, subtracting the x, no x left, negative 10. So this gives me a statement that is true. So in both of these cases, parts A and C, the variable pieces were the same on both sides. So when I added or subtracted them over, they eliminated each other and they were gone. No variables left is going to be true for both types. However, identify whether it's an inconsistent or an identity depends on if the numbers that are left are really going to be equal or if they're not, right? The previous one was not equal to, down here I do have equal to. So this is true, which means that this is going to be the identity type, and I need to write all real numbers as my solutions. Okay, and then we'll write our type over here. The type for this one is identity. Now, just because, oops, my page slipped. Just because it's interesting, all real numbers are supposed to make this original equation true, which means that we could check it for absolutely any number we wanted to, and we would see that we would get true. So we're just going to play with this one for fun. So let's check it. I can pick anything I want. So x equals, how about 2? All right, let's check it. So if I plug in 2 times 2 minus 5, plugging in that 2 right there for x, minus x is 2 again, equals 2 minus 10. Okay, so that's 2 times 2 minus 5 is negative 3, minus 2 equals, and then I know that 2 minus 10 is negative 8. Let's keep going. 2 times negative 3 is negative 6, minus 2 equals negative 8, and at this point you can see it's true. Negative 8 equals negative 8. So it does check. On your own, if you're interested, you could check this for absolutely any number. This was random. I just happened to pick a number, like 2, and it works. This is true for all real numbers, meaning that absolutely every number that you picked right here and plugged in for x is going to give you true. Kind of neat.